Today, across the nation, giant aircraft factories are working to build an air fleet second to none. We have pledged ourselves to this titanic job because we know that control of the air is essential to our defense. Defense of the air spaces above our homes and cities, and control of the air over military concentrations established by an enemy. The job of the interceptor and pursuit ship is to defend our own air theaters. The medium and long-range bombers provide power to strike at far-distant enemy concentrations. This is the projected defense technique which the RAF is employing with such success in Europe today. Our story of building a bomber begins in the Foundry, where the men wear asbestos clothing for protection against the terrific heat from the pots. The molten metals are cooked until impurities rise to the surface. A chemical compound is then added which smolders, finally catches fire, and burns the impurities away. This work requires a high degree of skill and stamina. Yet basically, it is not unlike many cooking operations which go on in your own kitchen. From the foundry come zinc dyes, lead punches, and castings, which are later used to shape the precision parts of the airplane. Here again, a fine art, centuries old, is employed to guarantee the utmost in precision workmanship. In the drop hammer forge, the lead punches and zinc dyes are locked in the big hammers. Aluminum sheets from the rolling mills are placed on the dies. Then the punches gentle the metal into shape and seal the shape with one final heavy blow. It is interesting to note that the drop hammer is one of the few machines which will press a sheet of metal into a reverse curve. Aircraft parts, most of them aluminum alloy, must arrive at the factory in a semi-soft condition so they can be worked without tearing. Later, they are treated in a chemical bath for hardening. The job of these great brakes is to bend and corrugate parts large and small. Note the delicacy with which these machines operate. A corrugated piece of metal has much greater strength than a flat piece. Here is the famous Yoder hammer in operation, a metal shaper long familiar to workers in American industry. This work requires a high degree of technical skill, too, since the operator must rely on the accuracy of his eyes and hands to form a perfect streamlined, curved surface. This moving drill press is a new development, an ingenious machine tool designed especially for American aircraft production. It is most efficient in the work of drilling wing spars, which are locked in place on a fixture. A steel template is locked over the aluminum spar. Then the driller moves back and forth, drilling through the template into the spar. Semi-skilled workers can be trained to operate this machine in 3 weeks, yet the work is accurate to a thousandth of an inch. Another remarkable new development for high-speed production is the hanging drill basket, a shaped hard metal form which fits securely over curved surfaces and is locked into place. Rivet holes in this leading wing edge must be accurate, so they'll be exactly in place over corresponding holes in the wing ribs when riveters start sewing the parts together. Precision is the first law of the aircraft maker. Then comes high-speed operation and the development of special production machinery which guarantees quantity production. The secret of efficient assembly line operation is first, a simple, accurate operation for each man. Second, perfect timing so parts move steadily to final assembly. Flat and gently curved aircraft parts are stitched together by this high-speed riveter on which a tiny spotlight is synchronized with a spot pattern traced on the metal. Then the riveter stitches like a giant sewing machine. Rivets must be kept in ice boxes where they remain contracted and soft. To speed up production, many aircraft manufacturers operate a small truck service which delivers rivets at the proper temperature to the workers. Rivets are inserted while they're soft. When they expand at normal temperature, they harden and strengthen the plane structure. Other parts of the plane, particularly wing spars, which require large-size rivets for additional strength, are stitched together by a squeeze riveter. One of the most ingenious developments of the aircraft makers is the explosive rivet. These tiny metal stitches are used only on blind surfaces where pressure cannot be brought to bear from both sides. Each rivet carries a small powder charge which is set off by a heated electric tool. Note how the rivets swell after they explode. Under the pressure of a speeded-up production program, aircraft workers are apt to become overtired, and this fatigue factor has caused serious concern among plane builders. Men working in cramped, uncomfortable positions have to slow down. Here is the production designer's answer to fatigue: a revolving jig which permits drillers and riveters to stand upright and work rapidly at a normal, comfortable position. In this minor subassembly, bulkheads are put together, then moved down the line to be riveted into the nose, center, and tail sections of the fuselage. Here, too, the bomber section is locked in a jig to ensure precision and accuracy. While many new machines have been developed in the rapidly expanding aircraft industry, the fixed and movable jig is of basic importance to assembly line production. More than 150 sizes of rivets go into each ship. Workers are instructed not to pick up dropped rivets because it wastes time. At night, machines pick up rivets, separate them from scrap material, then carry them to this machine which sorts them for further use. Each part of the plane is completed as nearly as possible before it joins a larger part. This light but strong crown section fits in the fuselage between the wings. Still another type of fixture holds the ribs of the fuselage firm while the workers put on the outer sheath of aluminum, the skin of the plane. The fuselage or body of the bomber has three major sections: the nose assembly, which houses instruments for the radio operator, the navigator, the pilot, co-pilot, and bombarder; then the center section, which must be built to carry a tremendous load of bombs; and finally, the fore and after tail section, which carries guns to fight off attacking planes. Into these sections must go the myriad parts which control the movements and fighting power of the bomber. All of them must be strong to withstand the terrific vibrations set up by air speeds of 350 to 400 miles an hour. Wing flaps must be light, yet strong enough to break the airspeed of the bomber while she's landing. Construction of the wing itself is just as complicated and important as the construction of the body. In a sense, it represents an even more painstaking effort on the part of aircraft designers. Streamlining and strength are all important. The smaller the wing surface, the faster the ship will fly. Then, too, as the size of the wing is reduced, the strain on its lifting power increases. So the wings have to be made stronger to hold the plane in the air. All these and many other factors are the problem of the plane designer, and the responsibility for executing his designs rests in the skill of these men. Together, they turn out planes guaranteed for maximum flight performance and safety. Steadily, the wings roll along the assembly lines, moving from minor to major subassembly, then to final assembly. Overhead, the great spans move as the skilled craftsmen in each department complete their work. This wing has just left the surface and floats department, where self-sealing gas tanks were installed. American engineers first developed these tanks, and they'll take the punishment of a 50 caliber machine gun bullet without losing a pint of gas. Wings must also be strong to hold the mounts for great motors and the mechanism for the heavy retractable landing wheel gears. The shark's mouth is a part of the empennage, a complete unit of the after tail section, which also supports the stabilizers, elevators, and rudder, which guide the bomber in flight. Here is the most vulnerable part of the plane. Damage to any of the important control surfaces of the empennage might result in the plane's complete destruction. And so, a gunner is stationed here to fight off enemy pursuit ships. And here are center sections nearing completion. Work goes on inside and out, even while they're moving to a new department. These almost finished parts, with bulkheads already installed, are waiting to roll into final assembly. Welding still plays an important part in building a bomber. Motor mounts and many other primary structures, which are subjected to great stresses, must be fused together by expert craftsmen who know their jobs. It is important to remember that welding even increases the original strength of the separate pieces. Expert technicians are now working on plans for an all-welded ship. But it takes years to train expert welders. On these men rests much of the responsibility for the safety of the ship in flight. Taking a leaf from the experience book of the automobile manufacturers, aircraft builders have installed moving belts of their own. Here you see aircraft assembly line production in one of its most interesting phases. For these intricate small parts must roll off the line in ever-increasing quantities if we are to meet the production challenge of a Hitler-controlled Europe. Certain secondary structure and control parts of the bomber require the use of the strongest metals available, castings made of magnesium and aluminum alloys. Every precaution must be taken to ensure absolute perfection, so each casting is X-rayed by a machine powerful enough to detect the slightest flaw. The rays of this machine are so penetrating that the operator must leave the insulated chamber while the camera is at work. It will photograph through solid metal parts several inches thick. Another type of flaw detector is the magnaflux, which reveals cracks on a metal surface invisible to the human eye. You'll understand how important these expensive operations are when you're informed that only 1% of all parts tested reveal an imperfection of any kind. More than 25,000 parts go into the making of each bomber, and this does not count nuts, bolts, and rivets. Faced with the necessity of trebling and quadrupling aircraft production as soon as possible, the large manufacturers are employing a system called subcontracting, which means farming out parts of their big contracts to smaller manufacturers over the country. This relieves some of the economic strain on manufacturers who do not have defense contracts and speeds up aircraft production. As soon as these parts reach the major factory, they are sorted and installed in the planes. All parts move to final assembly. Here is one of the great wheels built to withstand the shock of high-speed landings. From another major subassembly comes the nose section. As she rolls, you can see the complex instrument panel with its dials, gauges, and controls. Accuracy, precision, and speed are shown by the ease with which these fuselage sections are spliced together. Now the almost complete wing, carrying gas tanks and the motor wheel nacelle, moves along the assembly line. Here is the reward of careful planning, timing, and good workmanship. Spliced firmly together, the nose, center, and tail sections of the fuselage move overhead. Rolling on mobile jigs, the wings are spliced into the fuselage by powerful steel forgings. As soon as the wings are locked in, the motor swings overhead and is lowered to be bolted into the motor mounting in the wing nacelle. Note the oil tank separated from the motor by a firewall. Miles of wires, cables, and pipes link the nerve centers of the ship. All gas tanks have separate leads to the carburetor. The piano hinge on the leading edge of this wing permits easy repairs. Here, the giant powerhouse is bolted into the strong motor mounting. A skilled mechanic checks the gas line connections. High-octane gas is readily inflammable, and this part of the assembly requires unusual caution. Now we begin to see the great bombers coming to life. This is the final assembly where the last of the intricate pieces of mechanism are installed, the power turrets and the secret bomb sight. Before it leaves the factory, the bomber is camouflaged, an important precaution to render her invisible from the air and hard to see in the sky. Note the light underbody and the dark color above. The light, strong plexiglass nose is fitted into place, guaranteeing perfect vision below for the bombarder to sight his targets. Day and night, the big doors roll up so the bombers can be moved to make way for those which follow. She's not quite finished yet, but she has to keep moving along. Our modern aircraft production lines run clear to the flying fields, where all points of the plane are checked and rechecked. In the background, a new plant promises an even greater production of fighting ships. Here are ships of the line, awaiting a final checkup. When they're ready, the great four-bladed propellers are installed and the motors ground tested for perfect performance. One of the last and one of the most important checks is the testing of the landing gear. A faulty retractable landing gear may mean the loss of a ship on which tens of thousands of dollars and many thousands of man-hours of labor have been spent. At last, she's ready to take off, ready to respond to a rigid test which will submit her to all the pressure of combat conditions. Here is the medium bomber, fast and tough, perfect down to the last detail, and a perfect tribute to the designers, engineers, and craftsmen who are bringing thousands like her to life to help fight democracy's battle.